Hi, this is Jonathan Gardner. We're covering section 521 of Griffith's Introduction to Electrodynamics. If I go too fast, you can always rewind. Questions go in comments or a video response. And let's get started. So electrostatics was a study of charges that do not move. Okay, and the reason why we had to keep them stationary was because we didn't want to talk about magnetism and what really goes on there. So we just took a piece of tape and stuck those charges to particular positions, and then we examined the forces that would happen if we brought in a test charge. Okay. Similarly, for magnetostatics, we have to have a constant magnetic field. In order to produce a constant magnetic field, we need a constant current. The current cannot change throughout the problem that we're trying to solve, right? And he talks about a little bit of terminology. He says steady currents. He likes to use the word steady currents. That means they're not changing, okay? It's like constant velocity, steady velocity, okay? But some books they talk about stationary currents, which is kind of weird to think of. Like, you don't talk about a car going down the freeway 60 miles per hour as stationary. It just doesn't make any sense. Another thing that he talks about is that just like electrostatics doesn't reflect anything that really happens in the real world, it's surprisingly useful. Okay, there's a large number of real world problems that if you apply electrostatics to it, even though you know the charges are moving, you get the answer that is extraordinarily accurate. Okay. Likewise, for magnetostatics, even though in the real world you don't have any such thing as steady currents. At some time in the past you had to turn the current on, sometime in the future you're going to turn the current off, and so the end result is that in real life you never have anything like a steady current for some large period of time. But nevertheless, the results you can calculate doing magnetostatics apply very well to reality. So this approximation really is, it's assumed that it's going to work, and it does work. There's a little statement here. We cannot talk about point charges with steady currents. Why? Because point charges are here one moment and gone the next. Okay. We can only talk about continuous charge distributions, like linear charge distributions, something like that, where when one charge moves out of the way, another comes to replace it right away, instantaneously. And he has this comment. I love this statement. This is one of those things, classic Griffiths. He says, "This may seem like a minor thing to you, but it's a major headache for me." Right? So if you wanted to start talking about point charges that are moving, it seems to you like the student right now, you're saying like, why is that hard to calculate? And the answer is, it's hard to calculate because you need to bring magnetostatics and you need to bring electrostatics together in electrodynamics, which we do in 2 chapters from now. So the bottom line is, in magnetostatics, the divergence of the volume current is 0 in all places, everywhere, at all times. That means if there's a current flowing into a point, from that point an equal current must flow. Now it might spread out, right? You might have it, a large current flowing in from the bottom, and then it kind of flows out in 3 smaller currents, right? We see that all the time in electric circuit diagrams. You have this kind of chart. I'm terrible at this, by the way. Okay, so here we have, the currents here are 1/3 of the currents here, because the current splits up. It comes in here. I could have it backwards, who cares? And then it spreads out into 3 different branches as it crosses those resistors. But the point is in circuit diagrams, we don't have accumulating charge anywhere. Even capacitors, there's a current flowing through the capacitor. Even though one plate accumulates charge, the other plate accumulates another charge. The same thing for magnetostatics. There is no accumulation of charge. Okay, the divergence of the current, the volume current, must be 0 at all times in all places. And that's the bottom line. Thanks for watching. Be sure to share this with your friends. Hope you had a good time. Thanks. Bye.